So let's have a look at my third video from section 9.1. It's not going to be exclusively about using your calculator, but there'll be a lot of emphasis on using your calculator here. So now we need an actual problem to work on here. So we have here a KRC research poll, a fairly well-respected research firm. So I am going to assume that our sample was SRS. We had 1,002 respondents, and they were asked if they felt vulnerable to identity theft. And the sample proportion, that's the proportion of the people who said yes in this poll, was 53%. So now using a 95% confidence level, I want you to estimate a population proportion. Now you might be thinking, okay, I got a pretty good estimate here. I know that p hat comes close to the true proportion, and p hat equals 53%. So that's a pretty good estimate right there. And we call this guy the point estimate. And what I mean by a point estimate is our best single value estimate for the population proportion. Definition of a point estimate is for any parameter, though. In this case, for the population proportion. But that's not going to fly here. And the reason why that's not going to fly here is I don't have the 95% confidence that it's accurate. I don't even know what level of confidence I have. I know it's close. I don't know how accurate it is. So in order to achieve 95% confidence level, I need a confidence interval. Need a confidence interval. Specifically, a 95% confidence interval. And a 95% confidence interval looks like this here, where we take the point estimate, we subtract off 1.96, the critical value associated with 95%. If that makes no sense, go back and watch the critical value video, times the square root of p hat times q hat divided by n. And then the upper end of the confidence interval will be the point estimate plus 1.96 p hat q hat divided by n. And what this 9.6 is the critical value associated with a 95% confidence level. And if that is baffling you, go back and watch the confidence level video. Okie dokie, let me clear the screen and let's work this out. Okay, not only did I clear the screen, but I went ahead and put the formulas back near the top of the screen. So our p hat is going to be our population, our sample proportion. That will be the 53%. And from that I will subtract 1.96, and in the square root, I'm going to put 0.53 times 1 minus 0.53. And I'm going to divide all of that by 1,002. And then I'm actually going to erase this after I spent all that time writing it out. Normally I would just shove all of this into my calculator, but to make sure it's going into your calculator correctly, I'm just going to do one step here. Minus 1.96. What does this equal? I want you to get the same thing I got, which is 0.000, what was it? 25. That's rounded to 2 significant decimal places. And that is going to end up being, when all the dust settles, 0.0, no it isn't. This is going to end up being, you were wondering where that came from. I computed the margin of error, so why don't I just show off and show you what the margin of error is. Minus 0.0309. So the lower bound of my confidence interval is 0.4990. Okie doke. Doesn't look right. Hang on. Okay, I had some rounding error there, so that is going to be just using the values that I had here, because I actually did compute it out to more decimal places, but then I rounded. And so the upper edge of my confidence interval is going to be the point estimate plus 1.96 times the standard deviation. And so that's going to be 0.53 plus the same standard deviation. And just to be on the safe side, I'm actually putting this into my calculator as we speak, and here's what I've got. 5609. So now I am 95% confident that the true population proportion is inside this window here, where the bottom edge is, sorry, there's a decimal there, 0.4991, and the upper edge of my confidence interval is 0.5609. Now, I don't know where it is in that interval. It could be close to the bottom edge, it could be close to the upper edge. There is no guarantee that it is in the middle. However, how about using that calculator? Remember your calculator? Your calculator is so cool. Hold that thought. So now we have a whole new menu that we need to go to. We're going back to, happily, Stats. That's our first favorite button ever. Sorry, it's actually just Stat is what the button is called here. And in the Stat menu, we're going to go over two now. We're going to go over to Tests. So arrow over twice to the left or once to the right, and you're going to be in the Tests menu. And in the Tests menu, you're going to have to scroll down quite a ways. You want, I don't know which number it is because everyone's got a different calculator, 1 prop z int. So let's see what we're talking about here. Prop, I hope makes sense, stands for proportion. Z, because z-scores are normally distributed, this is a code word for using a normal distribution, because we don't always. And int is short for interval. We're going to be using a normal distribution because by the central limit theorem, if we meet that criteria, better talk about criteria at some point, we can use a normal distribution. So this is the option that we're going to be choosing to estimate a proportion. Now, if I go into 1 prop z interval, it's going to give me the following choices. And I think everybody's calculators looks exactly like this. Hallelujah. It's going to ask me what x is. It's going to ask me what n is. It's going to ask me for the sea level. No, not how many inches we are above the ocean, the confidence level. And then we get to choose calculate. And when we choose that, it'll calculate it for us. Let's talk about this really quick. X is the same thing it was back in binomial distributions. This is the number of successes, the number of trials that meet criteria. And this is going to be the number of trials, also known as the sample size. So that one's not confusing us too much. Don't know the number of successes. It's not given to me up here. What I mean is number of people, respondents, who said yes. And it doesn't say. What it says is 53% of 1,002 said yes. And 53% of 1,002, oh gosh, do I have this somewhere? Hang on a second. 0.53 times, 1,002 gives me 531.06. Now, if I put that into my calculator, I'm going to get an error message. Hang on a second, let me clear my screen because I've run out of space here. So if I put 531.06 in that space there, I'm going to get an error message. My calculator knows full well that however many people said yes, there wasn't 6/100ths of a person who says yes. X has to be a count. A count of something. The number of successes has to be a whole number. So I can compute that it's 531.06, but I'm going to have to round. No breaking of the rounding rules here, round normally. So what's actually going to go in that space on my calculator is going to be 531. It rounds down quite nicely. Number of people asked was 1,002. My confidence level, this has to be written as a proportion, 95%, and then I go down to calculate it, I highlight it, and I hit enter. And then I'm going to get, oh, hang on a second. Let me see what I'm going to get. Okay, I'm looking at my calculator right now. I'm going to get a whole bunch of information. Once I've hit calculate, it's going to give me at the top of the screen 1 prop Z interval, and then it's going to actually give me the confidence interval, 0.49904 on up to 0.56084. It's also going to give me a little bit more information. It's going to tell me what p hat was, just in case I didn't know it. And it is actually slightly different, 0.5299 and change. I'm not writing the rest of it in. And it's also going to tell me what n is. And I did put the n in myself. I should know what n is. But if looking at the screen I needed to know my number of successes, I'd be able to compute it back if I know this. So hey, presto, look at that. All it took was some entering into the calculator. Here is my confidence interval. Sorry, frequently abbreviated as CI, but this is what I've got here. Confidence interval. So this is actually the way I expect you to be able to compute your confidence interval. So you might be wondering why you needed the margin or error or the critical values. We are going to need them, so don't let that escape from you too quickly. But the next thing I want to do, I'm going to clear the screen here, and then the next thing I want you to do is I want you to work on this next problem, turn off the calculator, work on the next problem, and then we'll get back together and we'll do it together. Okay, here's my next example, so please stop the video at this point. I want you to see if you can come up with the confidence interval here. I know it just says estimate the population proportion, but you're not going to get a 95% confidence level without a confidence interval. And then come back to the video and we'll work it out together. Okay, this actually won't take very long because of the expectation that you're going to use the calculator. The hard part is, where in the calculator was this again? So this is in your stat button. You arrow over twice and you go to a menu labeled tests. It's called that because that's where all your hypothesis tests are. And in this menu you're going to have to scroll down until you find 1 prop Z int. And when you're in 1 prop Z int, it's going to ask you what's x, and you're probably going to say 492. It's going to ask you what's n, and you're going to say how about 806. It's going to say what's your sea level, and what do you think your sea level is? Don't forget, got to put it in as a proportion, not as a percentage, and then it's going to say, hey, okay, calculate me. And so we'll put in all of this stuff. We'll highlight calculate, we'll press enter, and here's what we're going to get at the top of the screen. It'll say 1 prop Z int, and then it's going to say, oh gosh, I've lost it. Oh, here it is. Haha. 0.57676 on up to 0.64409, and then it's going to say that p hat was equal to, oh, hang on. Don't know what p hat's equal to. Pause. Okay, according to my calculator, p hat is equal to 0.61 and change, and n is equal to 806. Okay, I'm out of time. So that's how you find your confidence interval. Here's your confidence interval. You are 95% confident that the true proportion is between 58% and 64%.